The incident in Amepo has vivkwan pil son sogopi molin jebeb dipso hosiai kuvudinam of gwifs. MP4 highlights critical systemic failures such as the use of improvised, unrated supports and the lack of stabilization mechanisms like wheel chocks, which render heavy equipment unstable and prone to collapse. Furthermore, personnel working directly within the potential impact zone of elevated loads represents a severe safety breach. To prevent such incidents, businesses must strictly utilize certified, rated jack stands that exceed necessary load-bearing capacities and implement two-layer safety protocols. Ensuring loads are transferred to fixed stands and verified for stability before work begins. Hazard awareness training is essential to ensure personnel treat areas adjacent to suspended machinery as restricted zones until mechanical locks are engaged. This incident warns against complacency. Workplace safety demands rigorous technical standards, regular equipment audits, and strict adherence to established safety parameters. Would you like a safety checklist for vehicle lifting? The incident in Instagram MP4 highlights critical safety failures, primarily a danger zone violation where a worker stood beneath a suspended load, a strictly prohibited practice due to the inherent risks of shifting loads or cable failure. The situation was exacerbated by inadequate load control, as improper rigging caused the object to tilt suddenly, and a lack of coordination left the operator without sufficient clearance to avoid the shifting material. To mitigate these risks, companies must strictly enforce no-go zones around crane operations and ensure thorough inspections of rigging and equipment are conducted before lifting begins. Employees require training to eliminate the hazardous behavior of standing near suspended loads, as workplace safety relies on technical procedures and disciplined compliance rather than individual agility. Would you like me to draft a safety checklist for crane operations? Handling large surface materials manually presents extreme risks, as these objects act like sails when exposed to wind, generating lateral forces that far exceed human strength. When combined with unstable ground, the loss become inherently unpredictable, causing them to fall with high-impact kinetic energy once their center of gravity shifts. This incident highlights a critical failure in risk management, specifically the reliance on manual labor for tasks requiring mechanical assistance like cranes or forklifts. Personnel were positioned directly within the line of fire without a clear retreat path, violating fundamental safety protocols. Professional operation must respect human physical limitations by prioritizing mechanical solutions and conducting rigorous field risk assessments, especially regarding environmental factors like wind speed. Ultimately, true safety requires the discipline to halt operations when conditions are unsafe rather than opting for hazardous, manual workarounds. The incident documented in Instagram MP4 highlights critical root causes, specifically equipment failure where materials were ejected due to improper securing procedures. The lack of machine guarding allowed these components to enter the workspace, while personnel violated safe proximity by working too close to active machinery, leaving no time to react. Essential safety solutions include installing protective cages or rigid barriers around moving parts and conducting regular maintenance audits on components like locking pins to prevent unexpected failures. Furthermore, companies must implement remote operational procedures, utilizing automated control systems to keep employees out of high-impact danger zones. This situation underscores that safety cannot rely solely on worker caution, but must be built on robust engineering barriers and strict zone control to minimize avoidable risks. Would you like me to draft a safety checklist for operational risks on mechanical equipment? The industrial press incident highlights the severe risks associated with dangerous points of operation, where high-force machinery cannot be halted mid-cycle once initiated. Accessing these areas without proper energy isolation represents a critical technical failure, further compounded by the absence of passive safety systems like light curtains or physical guards designed to automatically stop motion. Human factors, specifically workplace complacency and the prioritization of speed over safety, create a cycle of error that is frequently exacerbated by the breakdown of lockout, tag-out LOTO protocols. Prevention must rely on error-proof design and robust safety supervision, emphasizing that personal protective equipment is insufficient on its own. Companies must foster a rigorous safety-first culture that mandates strict adherence to LOTO procedures to prevent such incidents. Steel coils feature a cylindrical structure that possesses immense potential and kinetic energy when placed on uneven surfaces, creating significant risks if restraint systems like straps or locking mechanisms are poorly designed or inadequately installed. The cargo can easily shift. Once a heavy coil begins moving, it generates an inertial force that cannot be resisted by human effort, releasing extreme kinetic energy upon impact. Personnel standing in the line of fire during unloading face high risks, indicating a breakdown in workplace oversight and a failure to maintain safe separation distances. Strict adherence to keeping personnel out of the hazard zone is essential, and unloading must only proceed when secondary safety measures like wheel chocks are fully engaged. Heavy cargo inherently seeks equilibrium, and safety protocols must ensure that personnel are never positioned as a barrier. Transporting heavy loads with raised forklift forks significantly elevates the center of gravity, severely compromising the stability triangular site. Tainen lo ging kitikon tribing bexen engengi hihi en ningun len kovindi tuning in tune. Inji pi bnc dia yixi nugi the nundran viuli thodi bxc vong. During transit, environmental factors like floor unevenness or inertial forces from turns can easily cause the machine's tipping moment to exceed safe limits. Distraction, such as using a mobile phone while walking alongside active machinery, is a critical safety breach that prevents pedestrians from reacting to equipment instability. Effective industrial safety requires strict enforcement of the no elevated travel rule, prohibiting personal electronic device use, and establishing strict exclusion zones for unauthorized personnel site. Tainen la wei yingi confusion tribu d gix n and d gi ngn ingin in n nilen kau vd chun kujuming and tun. Yinze p li bi xi andru niu the known vio vien thodi bixi gexi into vong. Mi p4e. Pinch points occur not only between rigid surfaces but also when mechanical parts move towards stationary materials, creating zones of rapidly decreasing space. When personnel focus intently on material handling, they often experience a narrow focus that severely reduces situational awareness regarding surrounding machinery movements. This, combined with the absence of safety light curtains that would otherwise detect human presence and halt operations, transforms routine tasks into significant hazards. To mitigate these risks, businesses must adopt safety by design by ensuring a technical clearance of 0.6 dB to WM between material stacks and machines. Furthermore, installing emergency stops, automatic guards, and mandating a two-person protocol where a spotter monitors the area can effectively neutralize human error. Ultimately, technical discipline must override individual improvisation, as a proactive safety culture treats every minor error as a critical signal to re-engineer processes rather than blaming personnel. Would you like me to draft a comprehensive safety checklist to help manage these hazards?